An aircraft carrier is often called the most powerful weapon in the world. It's not just a warship, it's a floating airport, a command center, and a small city all rolled into one. They carry thousands of crew, dozens of jets, and can stay at sea for months, sometimes even years, without refueling. How? It all comes down to nuclear power. Let's break down how an aircraft carrier's nuclear heart keeps the whole machine alive. Traditional ships run on oil or gas turbines. But to understand why carriers went nuclear, let's think about scale. The USS Gerald R. Ford, the U.S. Navy's newest supercarrier, is over 1,100 feet long. That's longer than 3 football fields, and it displaces about 100,000 tons. To push that much mass through the water at 30 knots, you'd need an almost unimaginable amount of fuel. If the Navy tried to run carriers on diesel, they'd burn through millions of gallons of fuel every few days. That means constant supply ships, constant vulnerability, and a ton of wasted space. It simply wouldn't work. Nuclear power changes the math. A few hundred pounds of uranium can replace millions of gallons of oil. That's like trading an oil tanker for a suitcase. And that means more room for aircraft, weapons, and supplies, and far fewer refueling stops. So how does it work? Inside the ship are 2 nuclear reactors. Think of them as the beating hearts of the carrier. Each one contains fuel rods filled with enriched uranium. When a uranium atom splits, a process called fission, it releases heat, and lots of it. That heat boils water, but not in the way your kettle does. On a carrier, it's part of a closed-loop system. The water in the reactor gets superheated, then transfers its heat through pipes to another system of water, which turns into high-pressure steam. That steam spins enormous turbines, some connected to generators that supply electricity, others connected directly to the ship's 4 propeller shafts. In short, nuclear fission makes heat, heat makes steam, steam makes power. But the steam doesn't just push the ship forward, it's the lifeblood of the carrier. It powers radar systems that can track planes hundreds of miles away. It powers desalination plants, turning thousands of gallons of seawater into fresh water every single day, enough for cooking, drinking, and showers for thousands of sailors. And of course, it powers everything else: lights, kitchens, hospital equipment, computers, you name it. Nuclear power gives the carrier almost unlimited energy, which is why it can stay at sea for months or even years at a time. Here's one of the wildest facts. A nuclear-powered carrier can go 20 to 25 years without refueling. That's the entire career of some sailors, and the carrier never once had to top up its tanks. Compare that to a conventional ship that might need to refuel every few thousand miles. Eventually, though, the uranium fuel does run out. At that point, the ship goes into what's called a refueling and complex overhaul. This is a massive process that takes years. Workers cut open the ship, remove the old reactor core, and install a new one that will last the rest of the carrier's life. It's like open-heart surgery, but on a city-sized warship. A ship undergoing refueling and overhaul is put in a massive dry dock. Water is pumped out of the dry dock as the ship's keel rests on blocks. Now you might be asking, isn't it dangerous to put nuclear reactors on warships? It's a fair question, but the U.S. Navy has been operating nuclear-powered vessels since the 1950s, and their safety record is extraordinary. Carriers have 2 reactors, so if one fails, the other can keep the ship operational. The reactors are surrounded by reinforced containment structures designed to withstand combat damage. And the crews operating them, naval nuclear engineers, go through some of the most rigorous training programs in the world. In fact, in over 60 years of continuous operation, the U.S. nuclear Navy has had 0 reactor-related accidents at sea. So what does nuclear power mean strategically? It means independence. A nuclear carrier doesn't need fuel ships shadowing it constantly. It doesn't need to worry about tanker supply lines being attacked. It can cruise at high speed indefinitely, reposition anywhere in the world, and project air power without pause. This is why carriers are sometimes called 100,000 tons of diplomacy. The fact that they can stay at sea as long as the crew has food makes them unmatched tools of global presence. The newest carriers, like the Gerald R. Ford, still use nuclear power, but with more efficient reactors that require fewer crew to operate. Looking forward, many experts are talking about even more advanced reactors like small modular reactors or hybrid systems that could power future warships, drones, or even directed energy weapons like lasers. Nuclear power doesn't just make today's carriers possible, it may be the only way to power the weapons of tomorrow. So next time you see one of these steel giants on the horizon, remember, what makes it possible isn't just the jets on deck or the missiles it carries. It's the invisible nuclear heart, deep inside, splitting atoms to generate the power of an entire city and enabling the most powerful warship humanity has ever built. Thanks for watching. If you enjoyed this breakdown of carrier technology, make sure to subscribe for more videos on military technology.